So here we see the ohmic conductors and the non-ohmic conductors. We have done Ohm's law, and according to that, we are going to define the ohmic and non-ohmic conductors. The conductors which obey Ohm's law are called the ohmic conductors. Ohm's law is V upon I is equal to R. This was the Ohm's law which we proved, right? So the resistance is called the ohmic resistance. That means V upon I is R, means the ratio of V and I is a constant. Okay, so that means the graph between V and I is a straight line curve. It is a linear curve or straight line curve. And the resistance is given by the slope of these two, delta R upon delta I. In class 10th, you have learned how to take out the slope. If you are talking about delta V, means difference of V. Any two values of V we take, V1 and V2. Okay, this is V2, V1, and corresponding I1 and I2. So delta V1, V2 matlab hota hai V2 minus V1 and I2 minus I1. Right. So the value of the slope is the value of the resistance here. Then the examples are copper and silver. Next is your non-ohmic conductors, the conductors which do not obey the Ohm's law, which means that they do not obey this formula, right? The resistance is called non-ohmic resistance. That is, their ratio is not a constant ratio. You can say it is not, the graph is not a linear graph, and a graph is drawn somewhat here. At very low temperature or at very initial beginning, they do follow the Ohm's law, but finally they do not follow the Ohm's law, and the graph is not linear. The examples are electrolytes and diode valve. Okay, so one thing I want to tell you here is that in different questions also we have seen, if we have any graph like this and there are given, by this we can see if there are two lines which are showing the resistance of it, which one will be considered to be greater? Greater the steep, that is the greater value of the slope, the greater will be the value of the resistance. So here we see this, if we say this is at T1 temperature, this is at T2 temperature. So T1 temperature, जिसमें हम ले रहे हैं T1 is greater than T2. Okay, so T1 temperature, the resistance corresponding to this will be more than the resistance corresponding to this. Only if you have to see the graph and understand which value will be greater. The steeper the line, the steeper the graph, the more is the value. So if this is the value, this graph, we can say A or B. A will be, the resistance A will be greater than the resistance B. So this is how you differentiate. Then a very important definition is of superconductors. Now, conductors, you know that as the temperature increases, the resistance increases, and as the temperature decreases, the resistance also decreases. So for some conductors at very low temperature, what happens is that they lose their resistivity. Resistance zero ho jata hai. This type of conductors are known as superconductors. We define conductors which lose their electrical resistance at very low temperature are known as your superconductor. Okay. For example, helium becomes a superconductor at 4.2 Kelvin. 4.2 Kelvin. This is the temperature for helium to become a superconductor. So it will be good if you note it down.